try to solve it. It is an algebraic fraction. So go ahead and try and solve for this. We learned about these on Wednesday last week. So remember over here, because we're looking at fractions, we must always look for an LCD. Hello, everyone. Remember to look for an LCD, guys. Okay, when solving for this question, take it away. Hello, Mandisa. Hi, Sia. Hello, Desmarie. It's great to see you guys all. Hello, Tanelwe too. I'm just going to put that up there, just so we remember how to do this. Factorize the denominators first. Oh, Sia wrote physics today. Oh, I'm sure you did a lot better than what we're thinking. I feel like you're one of those people who are like, yo, it was so hard. And then we find out you got 80%. Woohoo! Well done, Mandisa. Very nice. Well done, my darling. Yo, Mandisa's just doing the best things. I don't know anything about economics, but I bet you did some great work. I've never had to do economics in my life, so I don't know anything about it.
Afternoon, ma'am.
Hello, my darling.
Ma'am, I just wanted to ask, so there was a message that was sent on the group saying, is that for like the results for 2023 for the learners who joined MathsLive last year?
Well, yes. So we want everyone to fill it in, even if you joined MathsLive this year. Okay.
So, ma'am, what do they mean by the end results, like the last
Your grade 9 final year results.
Oh, okay.
All right. Just so we can compare between what's happening in grade 9 and what's happening now in grade 10.
Yes, ma'am. Okay. Thank you.
All right. Okay. No, Sia, I feel like you're lying to us. I don't agree. I doubt it. Okay, let's have a look at this question on the screen quickly. All right, so like I say in my instruction over here, we're going to factorize the denominators first. Okay, so what I'm going to do is I'm going to go 7x, and I'm going to notice at the bottom over here, this x squared plus x, I can take out a highest common factor. Remember our default setting, guys, of x. So I'm going to take x out, and I'm going to have x plus 1 left, minus 5 over x is equal to 3 over x plus 1. Now, if I look at everything that I've got over here, if I need everything in my denominator to be represented, then I know that my LCD needs to be x and x plus 1. Now, remember, guys, that we need to look at restrictions. And restrictions are very important when we are making x equal to something, because when x is equal to something in the denominator, we can't have the answer undefined. So if I look at this x and x plus 1, I know that x cannot equal 0. And x is not allowed to equal -1. Because if I have any of those things, if I have x as 0 over here, I'm going to get 5 over 0, and that's undefined. So x cannot equal 0. And if I have -1 over here, I'm going to get -1 plus 1. That's going to give me 0 in the denominator. And that's also going to be undefined. So when I say that x cannot equal 0 and x cannot equal -1, it's because we cannot substitute either of those answers in there. All right, so we need to make sure that both of those are actually mentioned in this particular section. All right, then what I can do is I can see what each of my denominators is missing. I know that this part of my denominator isn't missing anything. So I can just write 7x over x times x plus 1 minus, now over here, I'm missing an x plus 1. So I need to multiply by x plus 1 here. And what I do to the bottom, I'm going to do to the top. So what I actually have on the top is -5 multiplied by x plus 1 all over x multiplied by x plus 1. And that is equal to, now over here, I'm missing an x because my LCD is x times x plus 1, but I've only got x plus 1. So there's x missing there. And whatever I do to the top, to the bottom, I need to do to the top as well. So in the top there, I then get 3x over x times x plus 1. Now, remember the nice thing about fractions or algebraic fractions is that when we're solving for x and we've got the same denominator everywhere, we can just drop the denominator. We don't really need the denominator because if the bottom is equal, that means that the top will be equal. So this part then goes away, and I've now got 7x minus 5 multiplied by x plus 1 is equal to 3x. And then we can just distribute in to find the answer we're looking for. I'm going to get 7x minus 5x minus 5 is equal to 3x. Okay, then remember anything without an x to one side, anything with an x to the other side. All right, so I'm going to then minus 3x on this side, minus 3x on that side. And then I'm going to plus 5 on this side and plus 5 on that side. So those two will cancel. All right, so now I've got 7x minus 5x, that's going to give me 2x. Minus 3x will give me negative x. So I will get negative x is equal to, now remember, negative 3x plus 3x cancels. Negative x is equal to 5, to positive 5. And I know that I don't want negative x, I want x. So I'm going to divide both sides by negative 1. Divide by negative 1. Those two will cancel. Therefore, x is equal to negative 5. And I'm writing all over the place. All right, okay, and that's the last thing we did in the lesson that we had on Wednesday. All right, welcome to MathsLive. I don't know if anybody's joining us for the very first time, but if you are, please just put a, hi ma'am, I am new, in the chat for me so that we can give you a nice big fat Watobi welcome. Hello, Amanda, I see you there joining us. Oh my goodness, did I just say Watobi? I meant MathsLive. I'm sorry, guys. I meant to say MathsLive. You guys know what I meant. All right. Okay, so please do let us know if you're new, and then we can help you catch up a little bit as we go. But today's lesson isn't actually on algebraic fractions. That's what we did last week, Wednesday. What we're actually going to be doing today is simultaneous equations. That's actually what we're going to be doing today. Now, who can tell me, what does the word simultaneous mean? Who knows? What does simultaneous mean?
Ma'am, does it not mean that there are multiple? Never mind. Wait.
Not multiples.
Like multiple answers.
Not really, not multiple answers. Sia's just letting us know that he knows nothing. All right. So if you Google the word simultaneous, Morangi, do you know?
Ma'am, I think it has something to do with things like happening at the same time.
Correct. Absolutely. Well done, lollipop for you. I need to get a lollipop like emoji so that I can just pop it on the screen whenever I need. This one belongs to Morangi. Well done, Morangi. Yes, simultaneous means at the same time, right? At the same time. So when we actually solve for simultaneous equations, we're solving for 2, sometimes 3, sometimes 4 things at the same time. Now, for us, when we do simultaneous equations, we're going to be solving for x and y simultaneously. We're going to be solving for both of them at the same time. And the way that we're going to solve for x and y is we can use 2 different ways. Okay, before I continue, can you give me a thumbs up in the chat if you've already done simultaneous equations at school, and the thumbs down if this is the first time you are seeing them? Let me know, peeps, so I know where to start. Mandisa says, yes, they've done it. Anybody else? If you haven't done it, please give me a thumbs down. Does Marie's also done it? Great. Sia's not done it. Okay. Tepo and Marangi say no. Tanuluti says yes. Okay. All right, that's fine. We're going to start all the way from the beginning, and we're going to try and explain. All right, so you guys will notice in the 2 equations that I've given you on the screen at the moment, and they will always be 2 equations, that I have two unknowns. What are my two unknowns? Who can tell me? If we look at both of these equations, what are the two things that I need to solve for here?
Is it not X, Y?
Correct, it's X and Y. Excellent. So you'll notice here I've got Y equals something, but the answer for Y has an X in it. Okay, which is a bit, I want an answer for X. I want Y equals a number and I want X equals a number. So what I'm trying to do is solve for these two things, basically using each other to get to the answer we want. And the way we're going to do this is we're going to do it in two ways. We are going to start learning how to solve by substitution. And then after we've done substitution, we're going to do elimination. All right. So we're going to follow a set rule of a set number of steps to get where we're going. All right. So I want you guys to follow along with me. If you're taking notes, and you should be taking notes, not if, because you're taking notes, right? We're going to start with substitution. So what I'm going to do is, first, I'm going to rewrite these two formulas. I'm going to go y is equal to x plus 4, and I'm going to number them. I'm going to number this one equation 1. And then I'm going to write y is equal to negative 2x plus 1. And I'm going to number this one equation 2. Now, numbering these two things is very important because we need to differentiate while we're working which of the two equations we're working with. So we're going to start by substituting, or we're going to start by naming them or labeling them 1 and 2. All right. Now, when we do substitution, what I'm basically going to do is I'm going to substitute into y. Wherever I see a y in any of the other equations, I'm going to replace y with x plus 4. Okay, so my next instruction is I'm going to say this. I'm going to say substitute. I'm just going to say sub equation 1 into equation 2, right? So wherever I see y in equation 2, I'm going to replace it with x plus 4. And if we look at our equation for equation 2, it starts with y is equal to negative 2x plus 1. That means what am I going to replace this y with over here?
X plus 4.
Beautiful. I'm going to replace it with x plus 4 because wherever I see a y, I'm going to replace it with x plus 4. So I'm going to remove the y and I'm going to say x plus 4 is equal to negative 2x plus 1. And voila, now we're only solving for x. So I want you guys to solve for x for me quickly and tell me what answer do you get for x? Whenever you're ready, you can shout out your answer. You can type your answer in the chat. Just let me know.
Ma'am,
Yes.
I'm not sure if it's correct.
Go ahead and tell me the answer, my darling.
It's a -1.
It is -1, correct. Tanuleti, was that you that unmuted just now to give me an answer as well?
Yes, it was the same one.
Same answer. Okay, excellent. Let's see how we got there. All right. I'm going to take negative 2x over to the other side, and then I'm going to take positive 4 over to the other side. I'm going to take some shortcuts now. All right, so I'm going to end up with x plus 3x is equal to 1 minus 4. Now, x plus 2x. Sorry, x plus 2x. My bad. I was testing you. You passed, Mandisa. You passed. Okay. All right, so x plus 2x will give me 3x. And 1 minus 4 will give me -3. And then I just have to divide by by 3 on both sides. Divide by 3, divide by 3. Therefore, x is then equal to -1. Now, I now know what x is equal to. X is now equal to -1. So what I'm going to do is I'm going to go back to equation 1. In fact, I could use either of these. It won't matter. I'm going to go back and I'm going to go into equation 1 and I'm going to sub in what x is. So I'm going to go in equation 1, y is equal to, I now know that x is actually -1. So where I see an x, I'm going to replace it with -1 plus 4. Now, that means, therefore, y is equal to -1 plus 4 will give me 3. And those are the two answers that we get. We are solving for x and y simultaneously. All right. Give me a thumbs up. Give me a thumbs down. How are we feeling?
Thumbs up.
Thumbs up. Thanks, Mandisa. All right. Are we all okay with this? Tanaretu's good with it. Those of you who are seeing this for the first time, are we okay? Do you want to try one on your own, or would you like me to do another example with you? All right, Sia, I'm happy to. I'm more than happy to. Can I use a different example this time so we can see how the steps work? Yes?
Yes, ma'am.
All right, excellent. Okay, so here's our next example. For those of you who are okay with what to do, you can go ahead and try this one. Solve for x and y simultaneously. All right, so I'm going to try and take it slow. Now, our first step, remember step number 1, is we need to label each of these. We need to call them equation 1 and equation 2. So I'm going to go y is equal to 3x plus 2, and I'm going to name that equation 1. And then I'm going to go y is equal to 2x plus 1, and I'm going to label that equation 2. Now, because we are using solving by substitution, we're going to say, let us substitute equation 1 into equation 2. That means that because in equation 1, there is y is equal to 3x plus 2, when I go into equation 2, wherever I see a y, I'm going to replace it with 3x plus 2. Okay, so my next step is to then take equation 2, and lo and behold, the first thing that comes up is a y. So I know that I need to replace this y with 3x plus 2. So I'm going to go 3x plus 2, that's where the y was sitting, is equal to 2x plus 1. And now I'm only solving for x, right? So we're just going to move things around. That one will go over there, and that one will go over there. So I'm going to end up with 3x minus 2x is equal to 1 minus 2. 3x minus 2x will give me x, and x is equal to 1 minus 2 is -1. I'm not done. What else do I still need to solve for?
Y.
For y, good. So now we can go back into equation 1. Because we know what x is equal to, we can substitute x for what it is. So we're going to say in equation 1, y is equal to 3, and then I've got an x, so that's going to be 3 times -1 plus 2. And that will equal 3 times -1 is -3 plus 2, and that is also equal to -1. And there we go. We've got one answer, x is equal to -1, and y is equal to -1. Sia, are we okay with that?
Yes, ma'am.
Excellent. All right. Can I give you guys one to try yourselves? Let me give you number
Can I
2. Yes?
No, I want to ask.
Yes.
For me, when I did it with my class at school, we
Yes.
also like said that if we put equation 1 and equation 2 together, it is equation 3. It is now called equation 3.
Yes. Okay. So we're going to talk about equation 3. So equation 3 normally comes in, maybe Tanulete, if I have to do this. Let's say, for instance, they didn't give me y is equal to something. So if they give me y minus 3x is equal to 2. Okay. Now, in this equation over here, I don't have y is equal to something or x is equal to something. So because I have to rearrange this equation, only after I rearrange it do I then call it equation 3. Okay, so in that case, what I would then do is I would take the -3x over to that side. And then after I've rearranged it, when I say y is equal to 3x plus 2, this then becomes equation 3 because it looks completely different to my equation 1.
Okay.
Now, but in this particular equation, because we didn't have to shift things around, there's no need for me to name it equation 3. Okay.
Yes, ma'am.
All right,
Ma'am?
good question. Yes, yes, ma'am.
Ma'am, for that you were just saying right now, right, ma'am? So when they give you like a number after the equal sign instead of a y, ma'am, both of the equations have a number after the equal sign.
Mm-hmm.
We were taught in a different way instead of what you just said now, with the taking the number to the other side.
Yes, that's called elimination. Okay, and we're going to get to elimination. I just want us to understand substitution, and then we're going to use these exact same examples to learn elimination. Okay, and I'll show you how those two kind of join together. All right.
Okay,
All right, my darling. Okay, we'll get to it. All right, here's the next one. Now, this one is a little bit ugly, right? Yeah, I actually don't like that one, not so much. All right, let's do number 3. We'll come back to number 2. Let's look at number 3. All right, now we're going to bump into a little bit of a problem. Yes, in that I don't have y is equal to anything, and I don't have x is equal to anything, but I can shift things around, right? So here's what we're going to do. We're going to take this first equation, and we're going to go 2x minus y is equal to 32. That is going to be equation 1. And then for the next one, I've got 7x is equal to 32 minus 2y. And that is equal to equation 2. Now, the problem is I can't substitute because I don't have y is equal to something or x is equal to something. But I know that in equation 1, I can see that there's a negative y there. Do we see how that y technically is on its own? Kind of, it's a negative y, but we're going to maneuver things around to make it y equals something. All right, that's what we're going to do. So what I'm going to do now is I'm going to say in equation 1, and I know that equation 1 says 2x minus y is equal to 32. If I want y on its own, what's the first thing I need to get rid of on this side, on the left-hand side?
2x.
Correct, the 2x, right? So I'm going to take 2x over to that other side, and it's going to become negative. So now I have negative y is equal to 32 minus 2x. But I don't want negative y, I want just y. So what can I do throughout this whole equation?
Divide by -1.
Correct, I can divide by -1 everywhere, right? Divide by -1. I can't just do it in one place. I must do it everywhere. So now if I divide by -1 everywhere, I'm going to get y is equal to, this is going to become negative 32, and that's going to become plus 2x, right? Now I've completely rearranged equation 1. So I can no longer call it equation 1. I now have to name it equation 3. And Thandolwethu, are you seeing where the equation 3 part of it comes in?
Yes, ma'am.
Good, because equation 3 looks nothing like equation 1, so we can't call it that. All right, now that we have that, we can go back and do the substitution part of it, right? So I can then say, instead of saying sub equation 1, which equation am I going to sub into equation 2?
Equation 3.
Correct, that's it. I'm going to substitute equation 3 into equation 2, right? So let's write down equation 2. I'm going to get, in equation 2, I'm going to get 7x is equal to 32 minus, now there's my y, there. That's the thing I need to replace with what I have over there. So I'm going to go minus 2 multiplied by my answer for y in equation 3, negative 32 plus 2x. All right, and now it's just a matter of multiplying in or out or doing whatever it is that needs to be done in order to get the answer. Right, first let's get rid of the brackets. Let's get rid of brackets. I'm going to distribute this negative 2 in. So I'm going to end up with 7x is equal to 32, and then a negative 2 times a negative 32 will give me a positive 64. And negative 2 times positive 2x will give us negative 4x. All right, and then we just shift things around. Anything without an x goes one side, anything without an x stays on the one side. So I'm going to take negative 4x over to the other side, and it's going to become positive 4x. So I'm going to get 7x plus 4x is equal to 32 plus 64 is 96. Am I correct? 96?
32 plus 54. Yes, ma'am.
96, good, 96. And then on this side, I'm going to get 7x plus 11x. That's going to give me 11x is equal to 96. Then the last thing I can do is divide both sides by 11. Divide by 11. All right, and unfortunately, 11 is a prime number, so I can't really divide by anything that would go into both of them, so x is just going to equal to 96 over 11. This was an ugly example. That's really ugly. But we're not done, right? Because we still need to go and solve for y. We only have x. So the easier equation for me to use to solve for x would be equation 3, because equation 3 already says y is equal to something. So I'm going to go and sub into equation 3. I'm going to say y is equal to negative 32 plus 2 times 96 over 11. All right, and then we can just punch that into a calculator. Will somebody punch it into a calculator for me and give me an answer?
I will. Ma'am, I don't know if it's my
Yes.
calculator, but it's saying 160, negative 160 over 11.
Oh, it should be something ugly like that.
Man, I think my calculator says it's 192 over 11.
Aibo. Oh, okay. I need to now get up and look for my calculator. Guys, how dare you make me get up? Okay, let me go get my calculator. Okay, terrible of me to be teaching a maths lesson without a calculator, but I hope I will be forgiven. Okay, let's punch this to a calculator. Let's see. Okay, negative 32 plus 2 times in brackets 96 over 11. I'm getting negative 160 over 11.
I got the same too.
Same. Morangi also got the same. Sia, what did you get?
I got negative 160 over 11.
Okay, all right. Okay, great. So we're all together on how to do this. The answers don't look so great, but the method is correct. Okay, can we try another question using substitution? I'm going to give you guys a chance to. Let me see. I think I'm missing a y. Yes.
If we said the answer, is it gonna be wrong or it's still right?
You mean if you click the SD button and get an answer?
Yes.
No, it won't be wrong. It won't be wrong, but fractions usually are more accurate than anything else. Okay, so if you click the SD button, the chances of your calculator giving you all the decimals is quite slim, because your calculator screen is only so big and it's going to cut off the decimals. Okay, whereas a fraction is exactly to be all the time. Okay, so rather leave it as a fraction. Okay.
Thank you, ma'am.
All right. Okay, let's try that one. Everybody try number 4. Pop your favorite emoji in the chat once you're done to let me know that you've got it. Okay.
Ma'am, can I ask a question?
Yes.
Ma'am, so for the previous equation that we did, I got
Yes.
192 over 11. But
190.
the others got 160 over 11.
Okay, so how did you put it into your calculator? Tell me what you wrote exactly on your calculator screen.
So, ma'am, so I calculated 2 times 96 over 11. which gave me 192 over 11.
Okay, yes, Tandulwetu, but there's a negative 32 in front of it here. So we must negative 32 plus 2 times 96 over 11.
Oh,
Oh, we forgot about the negative 32.
yes.
Yes. Okay. All right. Perfectly fine. It's okay.
Yes, ma'am.
Let's try number 4, everyone. Pop your favorite emoji in the chat when you're ready. Amanda trying to make us all hungry with her French fries emoji. Thank you very much. All right, peeps, 1 more minute. Ah, Sia, don't say that. Let's see if you've actually done the right things in a little bit. All right, peeps, that's time. Okay, so let's have a look at how we would answer these questions. Now, first thing we know is that we must label these. Okay, so I'm going to start with 10 is equal to 2x plus y, and I'm going to make that equation 1, and then y is equal to x minus 2. I'm going to name that equation 2. Now, luckily for us, in equation 2, y is already equal to something. So now, in my next step, I'm not going to say substitute 1 into 2. I'm going to say substitute 2 into 1. Substitute equation 2 into equation 1. Okay, because it's a lot easier in this case because of that. If you named yours the other way around, so if you made this one equation 1, and then you made that one equation 2, that's perfectly fine as well. Okay, that just that yours will read sub 1 into 2, which is perfectly okay. All right, so I'm going to go into equation 1, and now I've got 10 is equal to 2x plus, I see a y, so I'm going to replace my y with x minus 2. And now I can solve for x. Okay, my OCD is going to kick in for me, so I'm going to take all the x's over, and I'm going to bring the 10 over to that side. So I'm going to end up with negative 2x minus x is equal to negative 2 minus 10. Negative 2 minus 10. All right. So negative 2x minus x will give me negative 3x. And that is equal to negative 2 minus 10 will give us minus 12. And then we can divide both sides by negative 3, divide by negative 3, divide by negative 3. So those two will go away. So my answer will then be x is equal to 4. All right. And that's number 1. That's number 1. We're not done. We still need to then find what y is equal to. So I'm going to sub back into equation 2. And I'm going to say y is equal to, now I know what x is 4, so I'm going to replace it 4 minus 2, and that is equal to 2. So x is equal to 4, and y is equal to 2. How did we do, guys? Did we get it? Did we miss it? What happened? Let me know.
We got it.
Did you get it? Well done, Mandisa. Nice one. Everyone else, how did we do? Vanaka? Morangi, Sia, how did we do? Desmarine? Oh, Sia. Oh, no, guys. All right, if you did miss it, do you know where we missed it? Can we talk about where we missed? Oh, Sia, everywhere. Ah, la, la. Okay. Well done, Vanaka. Nice one. Okay, we need to have had a particular spot where things started going woof. So let's find that space. First part. You only got the first step correct. Okay, all right. So this does take practice, and simultaneous equations are quite tricky. So we do need to kind of get used to them. So I'm going to make you guys go and practice. Okay, remember, guys. Okay, one of my grade 10s in my class he said this, and it made so much sense to us that I put it on a poster in my class. Practice makes progress. Okay. And I really liked that Wanga said this. It's such a nice thing to say. All right. So the only way we're going to get better at this is if we practice. Okay, so we are going to be practicing a lot of these. Yes, Mandisa.
Ma'am, I'm currently doing a worksheet from school, and I am stuck on a certain question, and the equation is
Is it a simultaneous equation?
yes, ma'am.
Okay, all right, let's have a look. We might just find that it's uses elimination instead of substitution, but give it to me.
X plus y equals 7.
Mm-hmm.
And the other one is x minus y equals 1. Ma'am, how would you calculate that?
We just make that equation 1, and we'll make that equation 2. Now, all we need to do is decide which one of these do you want to rearrange. Do you want to rearrange equation 1 or equation 2?
Equation 1.
Okay, let's go with 1. All right. So what we want to do, Mandisa, is we want to choose. We either want to have, we're going to take equation 1. We either want to have x is equal to something, or we want to have y is equal to something. So I'm going to write it down. X plus y is equal to 7. Which one do you want? Do you want x is equal to or y is equal to?
X is equal to.
Okay, great. So we're going to isolate x. Now, if I want to isolate x, I'm just going to take y and move it over to the other side, right? So I'm then going to have x is equal to 7 minus y. And that's going to give me equation 3.
Yes, ma'am.
What's my next step going to be then?
You substitute equation 2 into 3.
Other way around. We must substitute
Three
equation
into
3 into equation 2. Correct. All right. So wherever we see an x, we're going to replace it with 7 minus y. So we're going to go into equation 2. And there, I see an x first. So I'm going to go 7 minus y is equal to 1. And then we just need to rearrange things. So my 7 will go over to the other side. And then negative y minus y will give me negative 2y is equal to 1 minus 7. So negative 2y is equal to negative 6. And then we can just divide by negative 2 on both sides. Therefore, y is equal to 3. Right? Now I know that y is equal to 3. And then I can just go back into equation 3 and sub in the value I have for y. I can go to equation 3 and I can go x is equal to 7 minus, there's a y, 7 minus 3. Therefore, x is equal to 4. Okay, so it's not always necessary for us to solve for x first. We can also solve for y first. Okay.
Thank you, ma'am.
Are we okay with this?
Yes, ma'am. Thank you.
Excellent. Good. Okay. So now what I want us to do, guys, is I want us to go back to question 2 over here. And we're going to use question 2 to learn about elimination. All right. So let's go all the way up to the top. Now, elimination is going to look a lot different to substitution. All right. But we're going to do the exact same thing that we did before. Right. So first thing we're going to do is we're going to label them. So we're going to go 7x plus 3y is equal to 13. And we're going to label that equation 1. And then I'm going to go 3x minus 7y is equal to 17. And I'm going to label that equation 2. Okay, so when it comes to elimination, what I want to do is I want to subtract the two equations from each other. Now, the problem that I'm having right now is when I subtract, I don't want to end up with an answer for x and for y. So I want to subtract to get 0 somewhere. Okay, I want to subtract to get 0 as one of my answers. Okay, so here's what I'm going to do. I'm going to take equation 1 and I'm going to multiply the whole of equation 1 by 3. Okay, so I'm going to go this part times 3, this part times 3, this part times 3. And that's the only way the equation is still going to hold. If I multiply straight through by 3. Okay, and that's going to give me 21x plus 9y is equal to 13 times 3 is 39. And we're going to call that equation 3. All right. And then I'm going to do the same thing to equation 2, but instead of multiplying equation 2 by 3, I'm going to multiply it by 7. Okay, so I'm going to go equation 2 multiplied by 7. So I'm going to go here times 7, times 7, times 7. All right, so I'm then going to get 3x times 7 is going to give me 21x. 7 times 7y is going to give us negative 49y. And that is equal to, oh my goodness, what is 7 times 17? 119. Okay. 119. ... And we're going to name that equation. Yes.
But why did we multiply by those numbers?
I'm about to show you exactly why. Okay. I'm then going to do that. And then my next step is going to be equation 3 minus equation 4. Okay, that's my next step. Remember, because what I want to do is I want to subtract to get 0. Now, if I subtract these two, 21x minus 21x, what are they going to give me here? I'm going to get 0. 21x minus 21x will give us 0. And then I'm going to go 9y minus negative 49. A minus and a minus is going to give me a plus. So now I've got 9y plus 49y. That's going to give me 58y. All right. And then over here, I also have to minus. I'm going to get 39 minus 119. Can somebody punch that into a calculator for me? What is 39 minus 119?
Negative 80.
Negative 80.
Yes, ma'am.
All right, beautiful. All right, so now I can solve for y because the x part is gone. So I can then divide both sides by 58. I'm going to divide by 58, divide by 58. And those two will cancel. Therefore, y is equal to, what is negative 80 divided by 58, guys? We can reduce that.
40 over 29.
Negative 42 over 29, 40 over 29.
Yeah, 40 over 29.
Good. And there we go. And now we have an answer for y. And we can go back into either one of those equations, either equation 1 or equation 2, and we can solve for x. All right, I'm going to sub back into equation 1. Okay, so I'm going to get equation 1, and I'm going to go 7 times x, or 7x, plus I've got 3, and there's a y. So I'm going to replace y with negative 40 over 29. 3 times negative 40 over 29, and that is equal to 13. All right, somebody punch that into a calculator for me. 7x minus something, minus 120 over 29. Minus 120 over 29 is equal to 13. And then we just have to take this over to the other side and we can solve for x. Okay, I'm then going to get 7x is equal to 13 plus 120 over 29. Okay, that'll be 7x is equal to
497 over 29.
497 over 29. Good. 497 over 29, but I still need to divide both sides by 7. Right, so divide by 7, divide by 7. Okay, so we can just take that answer that we've got, divided by 7.
Over 29.
71 over 29, correct. Therefore, x is equal to 71 over 29. What an ugly answer. I don't like that one. I don't like it. Yeah, it's not so great. Okay, so here's what we're going to do. We're going to take this one that we've had over here. Okay, and we're going to use this one to do elimination. All right. Okay, this one is going to go a little bit easier. Right, now if we do both of these over here, we can then start by numbering them. So we're going to go y is equal to 3x plus 2, and that's equation 1. And then I'm going to go y is equal to 2x plus 1 is equation 2. Now, is there any need for me to multiply either of these with something else? No, there's no need here, because if I subtract to get 0, I can just say y minus y, and that's going to give me what I want. Okay, so I'm going to say equation 1 minus equation 2. Now, if we do the math there, y minus y is going to equal to 0. And then I'm going to get an equals 3x minus 2x will give us x.
X.
And 2 minus a negative and a positive will give me a minus. So 2 minus 1 will give me plus 1. So now my equation reads 0 equals x plus 1. And I can then just solve for x by taking the negative 1, the positive 1 over to the other side. So I will then get that x is equal to negative 1. All right, are we all okay with this? Thumbs up. How are we feeling about substitution versus elimination?
Thumbs up.
Thumbs up. All right. Okay, I want to see if I can find us another example, one that's a little bit better than the ones that we've got here. Okay, because these are really nasty. I didn't mean to, guys. It was an accident. Okay. All right. Here's another example. Let's do this one. Hasia says, oh, Sia, sometimes elimination is better, but most times, you know, either or. It depends, all right, on what we're doing. Okay, here's one. I want us to try this one using elimination. X plus, no, wait, that's too easy. That's too easy. No, relax. No. Rewind. Let's not make it too easy. Okay. All right. 2x minus 3y is equal to 4. And Murangi, they're not. Okay, negative 4x plus 3y is equal to negative 20. And I want us to try using elimination. Now, remember, guys, your first step is to number them. It's to number. So start by numbering, and then you'll see if you put them one under the other, what you need to do from there. Okay. Give me a thumbs or give me your favorite emoji in the chat when you're ready. Sure, Amanda's already done. Damn, that's fast. Sure. I'll give everybody 1 more minute. All right, peeps, that's time. Okay, otherwise the lesson is going to end and we're not going to get to the answer. All right, first thing I'm going to do is I'm going to label 2x minus 3y is equal to 4. That's equation 1. And then negative 4x plus 3y is equal to negative 20. That becomes equation 2. Now, immediately I can see that I can minus these two because I have 3y and 3y. So that's exactly what I'm going to do. Right? I'm then going to go equation 1 minus equation 2. Right? So over here, I'm going to get I'm going to get 2x minus negative 4. That's going to give us positive 4. So we're actually adding. All right, so I'm going to get 2x plus 4x will give us 6x. Right, in the middle, I'm going to get negative 3y minus a minus and a positive will give us a negative. So negative 3y minus 3y will give us negative 6y. What did ma'am do wrong here? Oh, instead of minusing, I should be adding. Oh, guys, I'm sorry. I should be adding instead. I should be adding. All right. Sorry, because negative 3y plus 3y will then give us 0. Oh, I'm sorry. Okay, let's backtrack. Let's go back. All right. Equation 1 plus equation 2. Okay, I'm going to get 2x plus negative 4y. That's still negative, so that's going to give us negative 2x. And then over here, I'm going to get negative 3y plus 3y, which will then give us 0. And that is equal to 4 plus negative 20. That would give me negative 16. Right, so my equation actually reads negative 2x is equal to negative 16. And then I can divide both sides by negative 2, negative 2. Therefore, x is equal to 8. Okay, x is equal to 8. But I'm not done. I still need to find what y is equal to. I'm going to sub back into equation 1. So I should get 1. Equation 1 will give me 2. And I know what x is. X is 8. So I'm going to replace that x with 8. 2 times 8 minus 3y is equal to 4. I know 2 times 8 is 16. Minus 3y is equal to 4. I'm going to take the 16 over to the other side. Okay, and I'm going to get negative 3y is equal to 4 minus 16. And that is negative 3y is equal to negative 12. And then we're going to divide both sides by negative 3, negative 3. Okay, and that means y is then equal to 4. And those are the two answers. Okay, the two of you who actually got to finish, did you get the same answer, 8 and 4?
Yes,
Mandisa, how did you do?
I did
Good.
it correctly. But ma'am, I used my
Good.
own method.
You used which method?
Ma'am, it's kind of a long method to explain, but it was the one we were given in class where it's sort of like elimination.
Okay.
So you take the one equation, and then let's say we're taking 2x minus 3y equals 4. I would say I'm taking that equation, and then wait, ma'am. So I take out the x or the y, and then I move the 2 to the other side, and then I substitute like that.
Oh, so you use substitution, right?
Yes, ma'am.
Okay. Well done. Amanda used the exact same equation I used. All right. Okay, so here's what normally happens. This is why we have to choose between substitution and elimination, Mandisa. Because if I have 2x minus 3y is equal to 4 as equation 1, if I want to rearrange this so that x is the subject of the formula, what I'm going to do is I'm going to move the negative 3y over to the other side. I'm going to end up with 2x is equal to 4 plus 3y. And then I'm going to divide by 2 straight through. Then I'm going to get x is equal to 4 over 2 plus 3 over 2y, right? Which then gives me x is equal to 2 plus 3 over 2y. And me, personally, I don't like working with fractions. So when I see that if I isolate one of them, I'm going to get a fraction, I would rather use elimination in that process.
Yes, ma'am.
Okay, then elimination is the better option.